In 2018, there were on average 14 deaths every day, resulting in over 5,000 fatal workplace injuries according to the Bureau of Labor Statistics, or BLS. The aim of our project is to reduce the severity of workplace injuries and lower the frequency of fatal accidents by developing a cluster of sensors that can monitor workplace hazards such as suspended particulate matter, toxic substances, and excessive noise exposure. The cluster of sensors will communicate in an IoT or Internet of Things system using a microcontroller to relay information to the cloud. When first tackling this issue, we had to analyze exactly which environmental factors provided the most potential for human injury in workplaces like the Bechtel Innovation and Design Center, or BIDC. We thoroughly researched the subject, utilizing data from the BLS, the Occupational Safety and Health Administration, or OSHA, and other variety of sources, and we worked to narrow down this list of environmental factors to what we could detect using our sensor array device. The resulting list helped us decide exactly which sensors to use in our sensor array. They had to be effective in detecting a toxic substance and affordable in their implementation. Finally, once we had figured out which sensors to use, we were able to make decisions about the underlying software and other systems for sensor operation, data collection, storage, and power management. Our basic overview for the project is as follows. We researched OSHA's statutes for the pre-existing rules and regulations on chemical exposures, like how much of a certain substance can you be exposed to before OSHA can call it hazardous. Then, we found that OSHA has published a large data set on all of the severe injuries reported them from 2015 to 2019, along with a large database of chemical exposure cases from 1984 to 2019. We used that data and information to construct a list of sensors that we could use, and then compiled a list of the chemical exposure limits set by OSHA to be implemented in our machine learning algorithm. In the dataset of all reported severe injuries provided by OSHA from 2015 to late 2019, we were able to iterate through the dataset and construct a relative frequency table and decide on the specific nature of injuries we will target. From our analysis, we decided to target the following areas of interest: poisoning, effects of heat and light, coughing and throat irritation, and noise injuries, also known as ototoxicity. Through our research, we were able to analyze the list of substances found to be the most frequent troublemakers causing the most chemical exposures, and from there we were able to narrow down our list of potential sensors to the ones that can detect the aforementioned substances. For our sensors, we picked a wide range of digital and analog off-the-shelf components. We focused on the sensors that would cover the hazards found to be most common in our OSHA dataset. We shopped around to a few different electrical component vendors and made our selection on a few major criteria, such as sensing overlap and redundancy, cost and detection resolution. For our microcontroller, we have elected to use Rust instead of C because C lacks an official package management solution for external dependencies on microcontrollers. Rust has a package management solution known as Cargo, which will then make development much easier. Package management encourages code reusability, especially since safety standards can vary each year. Our decision to use Rust has come with some challenges, though. There is a high barrier of entry due to Rust not having a developed real-time operating system, along with different microcontrollers having different memory mapping schemes. Initially, we were looking to run it on Windows, but because OpenOCD is unavailable, we decided to use Linux. Eventually, we were able to use Linux to flash Rust onto our microcontroller. Because the project is in an early design phase, we still have a lot of things that we can improve and work on. But from the information we have gathered, our research suggests that an IoT advanced warning system, if implemented successfully, could be a low-cost alternative to many of the current safety systems employed by companies in factories and other different workplaces, and could potentially prevent some of the deaths and injuries happening in those said workplaces. We would like to thank Dr. Matthew A. Swaby for giving us guidance and the opportunity to present our research on workplace safety and providing us with the many resources the Bechtel Innovation Design Center has to offer. Thank you.